Hi students, good evening everyone. I hope all are doing well. Welcome to Infinity Learn by Sri Chaitanya. This is me Surya, your chemistry faculty from Infinity Learn. I hope I'm perfectly audible and visible to each and everyone present over here. So those who are watching particular session, just mark your attendance here. Okay, today in this particular session, we are going to discuss about the complete chapter of carbon and its compounds. In the last two sessions, we have already completed our first two chapters, right? Chemical reactions and equations and the acid, base and salt. So today we are going to discuss the carbon and its compounds. This is very important in the part of organic chemistry. This is the basics for the organic chemistry which we are going to discuss later in the grade 11 and 12 classes. Hi Harsh, good evening. Arush, good evening. Welcome to the session. So these are the major content we are going to discuss in detail about the chapter here. What do you mean by the carbon? What is the introduction part for the carbon? Then we are seeing the isomerism part, right? How we are explain the isomers of the carbon. Then IUPAC nomenclature, right? This is very important in terms of your board examination point of view. Then the functional groups, right? So whenever we are discussing about the IUPAC nomenclature, we will be discussing about the different functional groups. So we will be seeing the functional groups, how we are naming these groups along with their priority order. Then we are moving about the carbon compounds, mainly focusing on the ethanol and ethanoic acid. So let's start from our introduction part, right? Carbon and its compounds, which means that we are starting from the carbon part, right? So carbon is an element with the atomic number of 6, have a symbol of C, right? So it will be having an electronic configuration of, you can see, right? This is 2, 4, right? So as we already know how to write down the electronic configuration of different elements, right? So in the case of carbon, carbon is having the atomic number 6, which means that in first shell it will be having 2 electrons and the second shell it will be having 4 electrons. Total 2, 4 will be the electronic configuration of carbon with atomic number 6. So here the red part will be responsible for the electrons, positive part, right? As we already know, protons are present inside the nucleus, right? Protons and neutrons are present inside the nucleus and it will be having again 6 neutrons inside the nucleus. I hope you understand the image or the diagram for the carbon here, right? Now, while discussing about the carbon and its compounds, we are mainly focusing on the versatile nature of carbon, right? Carbon is having a special nature because of the presence of their ability to form covalent bonds, right? As we already know, what do you mean by covalent bonds? It has the ability to form the sharing of electrons, right? Covalent bond is formed by the sharing of electrons. So because of the tetravalency means it will be having the 4 electrons in the valence shell, right? As you can see over here, 4 electrons in the valence shell. So it can easily share these 4 valence electrons, right? So it will be known as a tetravalent element. Because of the tetravalent character and the small size, the carbon always forms covalent bonds as well as they have the self-combination property. Right, self-combination property is always known as catenation property. So because of this nature, the carbon is forming different carbon compounds, especially in the terms of hydrocarbons. Is that clear? Yes, the self-combination property of carbon is known as the catenation. So again the term is repeating here. The first part, it is the carbon always form the covalent bonds by sharing the electrons, right? Then carbon is tetravalent, it will be having a valency of 4 and it is the self-combination property. Self-combination property already known as the catenation property, right? Just repeating the same topic here for the versatile nature of carbon. Now let us see what is the Okay, we will be going to discuss about the terms of hydrocarbons, right? I will just give you a brief idea. Hydrocarbons means these are the carbon compounds in which carbon and hydrogen are the major components. We will be discussing detail about the alkenes and alkynes, right? Then you will get an idea what you mean by hydrocarbons. Now let us see the isomerism part of carbon compounds, right? What do you mean by isomers or what is the process of isomerism? Yes, Preeti, I am. Isomers means these are the compounds which will be having the same molecular formula, right? They are having the same molecular formula, but they have the difference in their structure, right? Difference in their structure or position of the functional groups, right? So this is the compounds which is having same molecular formula, right? But it have difference in their structures, either in structures or positions. So such type of phenomena or such a type of compounds are commonly known as the isomers. So mainly for the carbon compounds, we will be discussing the isomerism in part of two parts. One is the structural isomerism and another one is the stereoisomerism. In your examination point of view, you need to focus more about the structural isomerism. Stereoisomerism will be discussed detail in the case of organic chemistry chapters in the grade 11. So what will be the difference between the structural isomerism? Obviously, they will be having the same molecular formula, right? But they have the different structures. That's why they are known as the structural isomers. Okay. These structural isomers are again classified or divided into three types. First one, it is chain isomerism. Second one, it is position isomerism. And third one, it is functional isomerism. So let us see what are the position, functional and chain isomerism in detail. Okay, let us start with the chain isomerism. So as we already know, right, in the case of carbon compounds, there will be longest chain or the straight chain will be happen, right? Let us see one example here. Yes. What are you observing here? So this is the same compound of formula C4H10, right? C4H10. So what will be the difference between these two compounds? We have already discussed. If you are counting the number of carbon atoms, right, it will be containing C4H10, which means it is a straight chain compound, right? Yes, they will be having the structure difference, right? So here it is a straight chain compound. But if you are considering the second compound, the longest chain will be a 3 carbon compound, right? This will be a 3 carbon compound. And the next carbon will be present as a branch here. So it is a branched chain, right? So we can define the chain isomers are the isomers or the compounds that is having the same molecular formula, but they will be having different chain structures, right? Whether it will be straight chain or branched chain. Is that clear? Okay, isomers are the different types of compounds. They will be having the different structures. So we cannot predict whether it is acceptable or not, right? Whenever you are writing about the isomers of a compound, it will be containing more than one compounds, having the same molecular formula but have the different structures. While doing the IUPAC naming, you will understand how it is possible. Okay, now let us see the second type of isomers, that is the position isomers, right? So what will be the difference here? As you can see over here, right? Two compounds are given here. So what will be the name of this compound? Anyone? We have already seen the IUPAC naming of the carbon compounds. The first rule, we need to identify the longest carbon chain, right? So here I am taking the longest carbon chain. So I can see that this is the 3 carbon compound, right? If the number of carbon is equal to 3, the word root will be proper, right? There will be a proper table to find out the word root by using the number of carbon atoms, right? So this is the 3 carbon compounds, it will be prop. Then we need to start the numbering of the carbons, right? So according to our priority order, if any of the compound which is contained in the alcoholic group, we need to give the least number to the carbon atom that is attached to the OH group. I hope you got my point, right? So this is our alcoholic group or the hydroxy group, right? If any of the compound which is containing the OH group, you should give the numbering which start from the least number to the carbon atom attached to the OH group. So I will be starting the numbering from here, 1, 2 and 3, right? Now OH group, as we already know, this is the alcohol, right? Alcohol. So what will be the name of this compound? It will be propan 1-ol or simply propanol, right? Is that clear? Now what about the case of second compound? What is the position of this OH group here? So here no matter, right, if you are starting from here or here, in both the cases the number of carbon atom attached to the carbon atom will be least, that is having the number 2, right? So the name of this compound will be either propan 2-ol, 2-propanol or propan 2-ol. So what is the difference here? The difference in position of OH group in these two compounds, right? So that's why these compounds are known as the position isomers. Is that clear? Yes, 2-propanol or propan 2-ol is also fine. You need to mention the position of the OH group present in the compound. Okay, Shyam, what is the doubt here? So isomers are the compound which is contained in the same molecular formula but have the difference in their position, right? Position of the functional group or any of the groups present here. So while you are comparing these two compounds, the functional group present here is the OH group, right? OH group. So there will be different order to give the numbering of the carbon compound. So as you can see over here, this OH group is attached to the first carbon atom, right? First carbon atom here. So we can say that the compound will be 1-propanol or propan 1-ol or simply propanol. Then in the case of second compound, this OH group is attached to the second carbon atom, which means that the position of OH group attached to the carbon is different here. That is why these compounds are known as the position isomers. You should do practice more questions, then you will get a correct idea to name the compounds. Now the last type of, okay, this is another example. Now you can see, right? So what about the case of first compound? The longest chain is the 4-carbon compound, right? So for the longest chain, carbon is number is equal to 4 means word root will be but, right? So this is the alkene compound, I mean butane compound, in which OH group is attached to the second carbon atom, right? We need to start from the numbering in which the least number will be given to the OH group attaching carbon atom, right? So if you are starting from here 1, 2, 3, which means this OH group is attached to the second carbon of the compound. Therefore, butane 2-ol will be the correct IUPAC name of this compound. Now, what about the case of this one? This is a straight chain compound, right? So, this OH group is attached to the first carbon atom. So, the name of this compound will be either butanol or butane 1-ol. Clear? Now, as you can see over here, right, this is another type of compound. So, what you are observing here, instead of OH group, they are giving the functional group of triple bond, right, C, triple bond C. So, here the triple bond is present at the first carbon atom. So, it will be name will be given pen1I, right, YNE stands for the triple bonded carbon atoms. Then here, the position of triple bond carbon atom will be in between 3 and 4th carbon atom, right. Okay, we need to give the numbering from here. Okay, there will be two possibilities for the numbering here, right? If you are starting from here, it will be 1, 2, 3 and 4. Now, we need to consider the number of carbon atoms here, right? We need to identify the least number here. If you are starting from my left to right, so it will be forming second carbon atom. Therefore, we will be giving the name as pen2YNE. I hope you understand, right? So, numbering is very important in the case of naming of these compounds. So, depending upon the priority order, we need to give the number to the carbon atoms which is having the least number. There is no proper method to start from left to right. It is completely depending upon the functional group, right? Completely depending upon the functional group. So in general, we can say that carboxylic acid and sulfonic acid group will be having the more priority, right? If any of the compound which is containing the COOH group has a priority order, that we need to start from the carbon atom which is containing the least number. So there is no necessary to start from either left to right, right? We need to get the least number. If you are writing from left to right, whether it is getting the least number, that will be the correct numbering. If you are writing from right to left, if you are getting the least number, then that will be the right. So it is completely depends upon the functional group. Now let us discuss about the functional group isomerism, right? The name itself suggests that these are the isomers or the compounds that will be having the same molecular formula but difference in their functional groups, right? So some examples are given here. So as you can see over here, these are the two compounds which will be having the same molecular formula or same formula of C2H6O. So what will be the functional group given here for first compound? It is OH group, right? OH group means it is alcohol. The name of this compound will be ethyl alcohol or ethanol. Clear? Then what about the case of second compound? This functional group is known as the ether, right? If any of the alkyl groups in between oxygen is present, this is known as the ether. So these are the methyl group, right? So two methyl groups are present here. That is why the name of the compound will be dimethyl ether, or it is also known as methoxymethane, right? Is that clear? So these are the same compounds, that means compounds which is having the same molecular formula but have their different functional groups. For the first compound, the functional group is alcohol, and for the second compound, functional group is ethers. And some more others are there in your textbook for the functional isomerism. Just refer from your book. This is the last example for the functional isomerism. Again, C3H6O is the molecular formula of these compounds, right? So here, as we already know, we have already discussed, if any of the group which is containing CHO as the functional group, that is known as the aldehyde, right? So this is the 3-carbon compound, therefore it is known as the propanaldehyde. Or in IUPAC name, we will be given the name for aldehyde group as Al as a suffix, right? So this will be propanal. Okay, which point I want to repeat? Previous one or this one? So I'm repeating again in the case of this compound, right? So CH3, CH2, CHO, which means that they will be having a molecular formula of C3H6O. So as we already know, this is a functional group here, right? CHO is the functional group. This functional group is known as the aldehyde, right? Aldehyde. So in order to give in the name for aldehyde group, we are giving the suffix as Al, right? Al will be the suffix here. So we need to identify the first longest chain containing carbon atom. Here it is 3. So the word root will be prop, right? Word root will be prop and the suffix will be Al because it is the aldehyde group. Okay, I hope you understand. Now, yes, Arush, this is the ketone, right? Ketone groups. C double bond group is commonly known as the ketone group. And again, for the ketone group, when you are giving the name of the compound, the suffix will be ONE, right? Suffix will be ONE. So this is again 3-carbon compound, right? 3 carbon means word root will be propan. So the word root will be ONE. So propanol will be the IUPAC name of this compound and acetone will be the common name of this compound. Now what about the case of this compound? Again functional, these are 2 groups are present, right? One is alcohol and another one is a double bonded carbon. Now you need to focus on the priority group, right? So if any of the compound which is containing both hydroxy group and double bond as the 2 functional group, the priority order will be first goes to the OH group, right? OH group will be having more priority than the double bonded group, right? Double bonded carbon atom. Okay, from this part you can expect the examples for the functional isomerism. Maybe some of the formulas are given, you need to identify whether it is a functional isomerism or not, or you need to identify the IUPAC name of the functional isomers of different compounds. They will be given only the molecular formula, you need to write down the functional isomers of the compounds. In the case of allyl alcohol, right, as we already know, it will be containing the double bonded carbon atom, so we can call it as an unsaturated alcohol also. Fine, Arush? Now, how we can name this compound, right? This is the OH group and double bonded carbon atom. We need to give the numbering according to priority order, right? So, OH will be having the more priority, which means that we need to give least number to the carbon atom attaching to the OH group. So, I will be starting the numbering from here. So, it will be 1, 2 and 3. Clear how we are doing the numbering? Starting from the OH group, it will be 1, 2, 3. We need to give the numbering for the carbon atom. So, it will be 1, 2, 3, which means that the OH will be attached to the first carbon atom. That's why the name is becoming here. Prop stands for 3 carbon atom will be the longest chain here. And 2 stands for the position of double bonded carbon atom, right? This is the second carbon atom, double bond is present here. Then last one, 1 stands for position of OH group containing carbon atom. So proper 2 in 1 all will be the IUPAC name of this compound. Is that clear? Okay, you can share this session maximum to your friends, then the views will be high. Now let us discuss about the nomenclature of carbon compounds, right? We have already seen how to give the IUPAC naming of the carbon compounds, right? As we already know, it is based on the IUPAC, no need to by heart this, right? IUPAC, International Union of Pure and Applied Chemistry. So we need to focus on the rules here, right? As we already know, the first step is to identify the longest carbon chain, right? Longest carbon chain. So here you can see these are the examples to find out the longest carbon chain. As we already know, I'm just repeating here. So what will be the word root of this carbon compound? For this carbon compound, this is the 4 carbon compound, right? Longest chain will be 4 carbon compound. So the word root will be bute, right? So word root will be bute here. So now you can see over here, it will be containing only single bonds, right? Only single bonds. Such hydrocarbons compound. These are the hydrocarbons, right? Arush, I hope you are getting the difference between hydrocarbons, right? So these are the examples of hydrocarbons, which means this compound containing only carbon and hydrogen atoms, right? Carbon and hydrogen atom in which single bonds are present. If single bonds are present, we will be called these compounds as alkanes. So obviously the word suffix will be ane. So the name of this compound will be butane. Is that clear? Now again in the case of this compound, 2 carbon compound, right? What is the word root for 2 carbon compound? Yes, hydrocarbons are alkenes and alkanes. Depending upon the bonds present in between the hydrocarbons, they will be easily divided into either saturated hydrocarbons and the unsaturated hydrocarbons. If it is containing only single bonds, we are called as the saturated hydrocarbons. Most common example is the alkenes. And if it is containing either double bond or triple bond, we will be called as the unsaturated hydrocarbons. If it is containing double bond, it will be called as alkenes. And if it is containing triple bond, we will be called as alkynes. Clear? Yes, here word root will be eth, right? So what will be the name of this compound? Ethane, right? Because there is only single bonds are present. This is the example of alkane or the saturated hydrocarbons. Now you can see over here, right? This is the longest carbon chain compound. So what is the total number of carbon here? 8, right? So oct will be the word root here. Is that clear? Now this is known as the isopropyl. I think someone asked about the isopropyl, right? So it's isopropyl group. So it will be having the isopropyl as the suffix, as the branched here. We will be discussing in detail how to write down the names of the branched chain, right? So this will be the longest carbon chain which is containing the 8 carbon atoms. So oct will be the word root here. Okay, we have already seen that how to write down the root word for the carbon compound. So this is the word root, right? If you are having one carbon atom, it is meth. If you are containing 2 carbon atom, it is eth, prop, but and so on. So you must be aware about the word root depending upon the carbon atom. This is the basic part we need to focus to write down the IUPAC naming of the compounds. Clear? Yes, there will be more than 4, 5, 6 or 7 carbon compounds are present in the case of carbon compounds, right? 7 bonds will be present, 7, 8 are possible. Maximum 9 or 10 are also possible. Okay, allotropes of carbon, right? So can you please give any example for the allotropes? What do you mean by allotropes? The same compound will be, same element will be having the different physical state, right? So most common example for the allotropes of carbon will be graphite, fullerene, and yes, graphite and fullerene are the common examples for the carbon allotropes. Okay, as we already know how to write down the primary suffix, right? So it depends on the degree of saturation, which means if we are containing either single bonds or triple bonds or double bonds, right? If you are containing double bonds or triple bonds, it will be ene as well as yne, right? And for single bonds, it will be ane. This will be the primary suffix. Here they are giving just the ruling for the IUPAC naming of the compound. As you can see over here, if you are containing only one bond, the primary suffix will be ane, generic name is alkane, right? Then for 2 bonds, it is ene, right? This is alkene. And for three bond, which means triple bond, it will be containing yne as the primary suffix, also known as the alkyne. Then one more case is that if they are containing 2 double bonds, right? If they are containing 2 double bonds, its primary suffix will be a-diene. Diene stands for 2 double bonds are present. So alka-diene will be the generic name of this compound. Similarly, if you are containing the 2 triple bonds, right? If you are containing 2 triple bonds, it will be having the primary suffix of a-triene and the general name will be alka-triene. You can focus more on the practice question. You will be getting idea about how to name the compounds based on the number of double bonds and triple bonds. Then again, if you are having the, for example, if I am taking CH4 molecule, right? What is the name of this compound? So what will be the name of this compound? CH4, right? Or yes, methane, right? So methane. So if I am deleting if I am removing one of the hydrogen atom from the CH4 molecule, it is easily forming CH3, right? CH3 group. Now what will be the name of this compound? The name of this compound will be become methyl. The suffix ane will be changes to YL. Is that clear? I hope you can see the board here. It is alkene minus hydrogen atom, right? Alkene minus hydrogen atom will be having the suffix of YL, commonly known as alkyl group. Then if alkene minus hydrogen atom, right? If I am taking one alkene, then I am deleting one hydrogen atom, it will be forming alkenyl compound with the suffix of enyl. Similarly, if I am deleting one hydrogen atom from the alkyne group, right? Alkyne group, it will be forming general compound of alkynyl, which will be having the suffix of YNYL. This is the same example I have given here. If I am taking methane compound and just removing one hydrogen atom, it will be forming CH3, right? So the name of this compound will be become methyl because it is alkyl. Is that clear? Now we have discussed about the primary suffix, right? The next rule is to find out the secondary suffix. If you are containing any of the functional groups as the branched here, we need to give the name of the compound with the secondary suffix, right? Secondary suffix. So for example, you can see over here, if you are containing OH group, right? OH group. So as we already know, it will be alkane, right? To the alkane compound will be, yes, to the alkane compound we are adding the OH group. So obviously their secondary suffix will be become ol, right? Alkanol. Is that clear? What is the rule about this? I will try to write down the different names of alkynyl compounds, right? Take any one of the alkane, just remove one hydrogen atom. Think about that, whether it will be having 2 hydrogen or not. So in the case of alcohol group means it will be having the functional group of OH group, right? So if you are adding functional group as the alcohol groups here, obviously the secondary suffix will become OL, right? OL. And if you are taking the aldehyde group as a functional group, right? If you are having the aldehyde group as a functional group, obviously their secondary suffix will be goes to AL. So the name will be alkene plus al will be alkenal, and the name of this compound will be butene, that it will be butenal, right? Is that clear? Then I have a question for you. If you are giving the name of this compound, right? Name is already given. How to write down the structure of this compound? How to write down the structure of this compound? So this is the another question you can expect from the carbon and its compound from the IUPAC nomenclature part. First thing, you need to identify the IUPAC naming of the compound from the structure, right? Second thing, you need to identify the structure from the IUPAC name. So how we can do the structure of this compound? How we can write down the structure of this compound? Butenal, right? Okay, just try to write down the structure of this compound. Take it as a homework. Again, some of the functional groups are given here. If you are having the halogen groups are either chlorine, bromine or iodine, obviously the name of this compound will be halo, right? Whether it will be, if it is chlorine, it will be chloro. If it is bromine, it will be bromo. If it is iodine, it will be iodo, and so on. Similarly, another functional group is nitro group, that is NO2 group. And if you are containing NO group, this is nitroso group. And for OR group, it is known as the alkoxy group. So you must have idea about the name of different functional groups in order to give the naming of the compound. So this is our major rule to find out the IUPAC naming of any of the compound, right? So what we need to do first, we need to identify the longest carbon chain, right? So from that you will get the root word. Then if you are containing any of the alkyl groups or any other groups at the chain there, branched chain there, you need to give them as the prefix, right? Prefix. Then you need to give the primary suffix. Primary suffix will be either double bond, single bond or triple bond, right? Then secondary suffix means they will be considering the functional groups. So this is the general rule to find out the IUPAC naming of any of the compound. Is that clear? Is there any doubt? Okay, we are just trying to cover all the chapter in one live session. We have already completed this chapter by using 7 parts, I think 7 or 6 parts, which is already recorded there in the channel. Okay, this is again giving the names for the primary prefix, right? So you can just give the primary prefix also there, depending upon the compounds. And again they are giving the example for the secondary prefix. If you are depending upon the functional group, if they are containing the different functional groups, we will be given the numbering of the functional groups depending upon the priority order, right? So most commonly the COH group will be having the more priority than all other functional groups. So I hope you can see the board given here. So this is the different functional groups and their name. If they are containing halogen groups, it will be having the name of halo group. If it is C double bond, alright, it is easily known as oxo group or the keto groups. Then for R group means it is alkyl group. Then for OR group it is alkoxy group. If it is containing carbon and nitrogen, cyano as the functional group, it will be give the name as cyano group. Then this is the other functional group COOR, that is known as the alkoxy carbonyl. So you can expect high level questions for the naming of compounds depending upon these functional groups. So this table is very important. Then if you are containing NH2 group, the name will be amino group. For NO2 group, it is nitro group. For NO group, it is nitroso group. Here the main point you have to keep in mind that if you are containing the CHO group as a secondary suffix, you need to give the name as formyl, right? Not it is alkyl. If it is not Al or any other name, this will be formyl. And for if you are containing the OH as the one of the functional group as a secondary prefix, right? If you are having the second priority for the OH group, you should give the name as hydroxy, right? This is very important. So SO3H is the sulfur group and CuNH2 is the carbamyl group, right? So this table is very important to identify the secondary prefix for the different functional groups given here. So just giving an example here, try to write down the name of this compound. Name is already given. What is the first rule? Arush, while we are discussing about the chemical bonding chapter, you will get an idea about the bonds, right? Then you will get a correct idea what you mean by the double bond and single bond. As we need to identify the longest carbon chain, right? So which one is the longest carbon chain here? That is the total number of carbon in the longest chain here. It will be 4 carbon atom, right? 4 carbon compounds, so the word root will be but here. Now what will be the primary prefix here? If you are containing any of the alkyl group as a branched chain, you need to give them as the primary prefix, right? Primary prefix. So first we need to do the numbering, right? So I have already mentioned if you are containing the hydroxy group as a one functional group, you should give the carbon atom to the OH group containing carbon atom to the least number, right? So there will be two possibilities, right? If I am starting numbering from here, what is the number of carbon atom attached to the OH group here? It is 3, right? If I am starting from here, the number of the carbon atom attached to the OH group will be 3 here, right? I hope you are getting the point. Now, if I am starting from this side, 1, 2, 3 and 4. Now, the carbon atom will be having a number of 2, right? So, as we already know, if you are comparing number 2 and 3, the least number will be 2, right? So, these type of numbering will be very correct. Is that clear how to do the numbering? So, as we already know, numbering already done, which means that third carbon atom is containing a methyl group, right? So, 3 methyl but ane. Ane stands for all the bonds are single bonds, right? Then plus 2-ol. 2-ol means second carbon atom is containing OH group. So what will be the name of this compound? 3-methyl butan 2-ol. Is that clear how to do the naming of carbon compound? Okay, from the root word means we are giving the name of the compound depending upon the carbon numbers, right? So from the root word itself, we can identify the number of carbon atoms. For example, if you are given the, just given the name of this compound, right? So this will be the root word. But will be the root word here, which means that we can identify the total number of carbon atoms present in the compound. Clear? I mean, total number of carbon atoms present in the longest chain. So it will be but stands for 4 carbon atoms are present in the longest chain. Okay, now to give the root words, we are considering the longest chain, right? Not about the complete chain. Arush. Okay, this is another example. Just try to find out the IUPAC name of this compound. First step, we need to identify the longest chain, right? Longest chain containing the carbon atom. So as we already know, it will be containing the total number of 6 carbon atom, right? So word root will be hex here. Then while giving the numbering, right? While giving the numbering, as we already know, if you are containing OH and double bond together, you need to give the priority to the OH group, right? So OH group. So I am starting the numbering from here. So now you are getting the second position carbon will attach to the OH group and third position carbon will be attached to the double bonded carbon, right? So final, the name of this compound will become 5-methyl hex 3-ene-2-ol. Clear? It's according to the IUPAC rule. Is that clear how to do the naming of this compound? Just try by yourself how to find out the name of this compound. So practice more questions to get an idea about the naming of the carbon compounds. You can expect this type of compound, is this type of questions from your examination point of view. Yes, ENE represents a double bond. Clear? ENE represents a double bond. If you are containing any other groups, it will be removing EN. It will be removing E here and the remaining part will be the functional group there. Clear? Now let us discuss about the case of functional groups, right? As we already know, different functional groups as the hydroxy group or the alcohols or aldehyde. Now let us see detail in terms of functional groups, right? These are the specific groups which give responsibility to the different characteristic chemical reactions of the molecule. As we already know, we need to focus different functional groups here. So as we already know, right, OH group means it is alcohol. ROH will be the general formula. SH, instead of oxygen, if the sulfur is present here, these compounds are known as the thioalcohols. Thioalcohols, general formula will be RSH. Then these are the compounds which is having the functional group as halogen. Commonly it will be either chlorine, bromine or iodine. So these compounds are known as the alkyl halides, right? Alkyl halides. R stands for the alkyl groups. For example, if you are taking CH3Cl, right? So this is known as the methyl chloride. Arush, is that clear? So these are the different functional groups. NH2 group is the amine. CHO, as we already know, aldehyde, right? C double bond O is the ketone. CONH2 is the amide. And COOH is the carboxylic acid. COR is the esters. And CR dash is the ethers, right? These are the different types of functional groups we have to focus in order to get an idea about the naming of compound. Now it is discussing about the case of alkynes, right? So as we already know, in the case of hydrocarbons, we have already discussed about the different types of carbon compounds, right? They are hydrocarbons. It will be dividing into saturated and unsaturated hydrocarbons. If any of the hydrocarbons containing only single bonds, they are known as the alkanes, right? They will be having the general formula of CnH2n plus 2, where N is the number of carbon atoms. For example, if I am taking the number of carbon atoms is equal to 2 here, so the general formula of the second carbon compound will be C2H6, right? Is that clear? How to write down the general formula of a compound? So this is the general structure for the alkane. Single bonds are present. CnH2n plus 2 is the general formula. Depending upon the N values, you will be getting different carbon compounds for the alkene series, right? So first alkane will be methane. The next alkane will be C2H6 or ethane, right? So if you are taking, this is a series. Okay, if you are taking a series of these alkane compound, you can see that if you are taking the difference between these two molecules, there will be a difference of CH2 molecule, right? There will be a difference of CH2 molecule. So such type of series is known as the homologous series. So these are the examples of the alkane series here. First compound is the methane, second compound is the ethane, this is propane, and fourth one is the butane. The next type of hydrocarbon is the alkenes, right? Alkenes means they are containing double bonds. Their chemical formula or the general formula will be CnH2n. The first alkene compound will be C2H4, right? C2H4. Or we can written it as 2 carbon compound in which double bond is present. All other valencies are satisfied by the hydrogen atom. So this will be the structural formula of C2H4 or ethene. There is a small correction, it is alkene. Is that clear? Are you familiar with the heterologous series? So these are the compounds and their structures. So C2H4 is the ethene molecule, 2 carbon compound containing double bond here, and this is the compound which is containing 3 carbon compound which is having the double bond, right? So this is the compound having the name of propene or propylene. The last one, it is the butene, right? C4H8 will be the chemical or the general formula of this compound, butene. Now the last type of compound is the alkynes, right? Alkynes means they are contained in the triple bonds, right? They are contained in the triple bonds. So their general formula will be CnH2n minus 2, right? CnH2n minus 2, which means that if you are taking C2 here, right? C2 here, the first compound will be C2H2, or it will be written as C triple bond C HH, right? So this is the simplest alkene compound known as ethine, or their common name is acetylene. Is that clear? So this is the basic introduction part of the hydrocarbons. So again, these are the ethine compound, the first carbon compound. Next one is the propane compound, 3 carbon compound containing triple bond. And for here it is 1 butane, right? So as you can see over here, this is a 4 carbon compound. Triple bond is present in the first carbon, so it will be 1 butane. And here it will be 2 butane, right? 4 carbon compound in which the triple bond is present at the second carbon atom, right? Second carbon atom. Now the next functional group is about the alcohols. As we already know, there is no any more explanation, right? Alcohol is having the functional group of OH. Their name will be end with the suffix of OL, or simply known as alkanol. Clear? So these are the examples for the alcohols given here. OH group is the functional group here, and name will be ends with the suffix of OL. So they are just giving the naming of here, we have already seen. These are the examples. If you are containing one carbon atom with the OH group, the name will be methanol. This is the structural formula. And second one, it is ethanol, structural formula. Third one, it is propan 1 all. There will be two isomers present, right? These propan 1 and propan 2 all are the position isomers, right? Position isomers. Then these are the examples for the 4 carbon compound containing OH group. This is again position isomers. Clear? Now the next functional group is the CHO group, right? CHO group is already known as the aldehyde group, right? Aldehyde group. While giving the name of this compound, we will be given the suffix as Al, right? So this is our aldehyde group. This is the functional group C double bond OH, right? So RCHO, or we can simply write it as the aldehyde group, or the suffix will be Al. Alkanal will be the name. So try to find out the more questions based on the naming of this compound. Naming of this compound based on the functional groups, right? So these are the examples. First compound, it is HCHO, right? HCHO. Only one carbon atom is present here. So IUPAC name will be methanol. Their common name is formaldehyde. Then the next example is CH3CHO, right? As we already know, two carbon atoms are present. So the word root will be ethane, right? Ethane will be the word root here. Suffix will be Al. So ethanol will be the IUPAC name of this compound, and their common name is acetaldehyde because it is derived from the acetic acid. Then again, this is CH3CH2CHO, 3 carbon atom. Propanol will be the IUPAC name. Common name is propanaldehyde. So try to find out the name of this compound. 4 carbon compound. So butanol will be the IUPAC name and butyraldehyde will be the common name here. Okay, same repeating here in the case of aldehyde we have already seen, right? How we can write down the name of the case of aldehyde. Okay, I think you can see here, right? There will be 2 aldehyde groups are present, right? 2 aldehyde groups are present here. That is why the name will be given as dial. This is the total 5 carbon compound. The word root will be pentane, and this will be containing 2 aldehyde groups. So it will be given as pentane dial. And here it is again butane dial, right? 4 carbon compound in which 2 carbon atoms are aldehyde groups, right? The name will be butane dial. The last functional group is the ketone groups, right? Ketone groups means they will be having the functional group of C double bond O. Okay, C double bond O, which means the ketone group. It will be having the suffix of O-N-E. While you are giving the name of this compound, you will be having the suffix as O-N-E, or it will be commonly known as the alkanone. So this is the example for the alkanone compound here, or the ketone compound here. So try to find out the IUPAC name of this compound. Again, examples are given here. The first column is the common name and the second column is the IUPAC name. While completing the session, just try to write down the structure as well as IUPAC name of this compound. Just take it as an homework. Again, some other examples are given here. Because of the time limit, I am not explaining completely. We have already discussed the naming of ketone compounds, right? The last functional group is the carboxylic acid group, COOH group, right? COOH group. So we commonly give the name as carboxylic acid, or the suffix will be oic acid for the naming of carboxylic compound. Again, examples are given here. To find out the case of carboxylic acid, try to find out the IUPAC name depending upon the carboxylic acid given here. Now the last part about the case of carbon compound is the ethanol and ethanoic acid, right? Which is already given in our NCERT textbook. You just want to remember the reactions based on the ethanol, right? Ethanol and alcohol. Ethanol is a part of alcohol which is containing 2 carbon atoms, right? 2 carbon atoms. So these are the volatile liquid having a boiling point of 78.37 degrees Celsius, right? So again, this is the structural formula and molecular formula, as we already know how to write down the molecular formula of the compound, right? So this is the structural formula of the alcohol or ethanol given here. And again, I am giving some of the examples for the reactions of the ethanol, right? So this part is very important. So just try to memorize the reactions of the alcohol part, right? Ethanol part here. It is already given in the NCERT book, that's why I'm not repeating again. Okay, after completing the session, you can get the session PDF from our Telegram channel. So you can just take a note of it. The last compound is the ethanoic acid. Again, this is a carboxylic acid containing group. Ethanoic acid, right? COH group which is containing 2 carbon atoms. Again, some of the examples are given for the reactions of carboxylic acid given here. The last part is the esterification part, in which alcohol as well as acids are combined together to form the ester. This is responsible for the ester formation. That's why this process is known as a esterification. Okay, these are the last part from the carbon and its compound part, ethanoic acids and their properties. So we have seen the ethanol and their reaction. We have seen the ethanoic acid and their reaction. Then when we are treating both ethanol and ethanoic acid together, they will be forming an ester. That process is known as the esterification. Okay, that's all about from my side for today. I hope you understand the main important points from the carbon and its compounds, right? So this part is very important. I'm repeating again, isomerism part, IUPAC naming of the compounds and the properties of ethanoic acid and ethanol are very important part according to your exam point of view in the case of board examination. So try to find out the more practice questions based on the IUPAC naming. So I hope you guys enjoyed the session. If you really like the session, hit the like button, subscribe our channel, share this particular session to your friends maximum. Then if you want to get the session PDF, you need to join our Telegram channel, Infinity Learn 9 and 10 Telegram channel. You will be getting the session PDF there after every classes. So thank you so much all of you. See you in the next class. Bye.